Welcome to The Explainer. In the race for AI supremacy, it often seems like the biggest models are the ones that always win. But today, we're breaking down a new open source contender that's making some serious waves by being smarter, not just bigger. Its name is GLM-4.5.
So, what's the ultimate goal in AI? Well, it's always been to move beyond just simple chatbots, right? The real dream is to create true general problem solvers, models with the kind of cognitive abilities that can tackle almost any task you throw at them. And to get there, a model really needs to master three deeply connected skills. First, it needs agentic abilities. That's being able to use tools and interact with the world. Second, complex reasoning to solve those tricky multi-step problems. And third, advanced coding for real-world engineering tasks. Let's just call this the ARC trifecta. So here's our plan. We're going to start by looking at this bigger quest for intelligence and a really critical gap in the open source world. Then we'll introduce our contender, put its performance to the test, and really unpack the secret sauce behind its success to see why this model is such a huge deal.
Okay, let's zoom out for a second and look at the big picture. The ambition in AI for years now has been to build models with human-level smarts, not just for one thing, but across a huge range of different challenges.
And therein lies the problem. While the proprietary giants like OpenAI and Anthropic have models that are amazing at specific ARC skills, the open source world has been waiting for that one single model that can truly master all three. That gap has been a major hurdle for researchers and developers everywhere.
And that brings us to the new kid on the block, the contender that's aiming to fill that very gap. This is GLM 4.5, and it comes from the combined team at Zipu AI and Tsinghua University.
So what exactly makes GLM 4.5 tick? Well, it's built on something called a mixture of experts architecture. Think of it like this. It has this massive library of 355 billion experts or parameters. But, and this is the really clever part, it only calls on a small, specialized team of about 32 billion of them for any given task. This is what makes it so incredibly efficient. This is where you can really see its underdog story come to life. This chart here plots coding ability against model size, and you see GLM 4.5, it lands right on what's called the Pareto frontier. That's just a fancy way of saying it hits the absolute sweet spot, delivering top-tier performance without all the bloat of its bigger competitors.
And to put that into perspective, just look at the raw numbers. GLM 4.5 has less than a third of the total parameters of a model like AIME K2. But get this, it activates the same amount of brain power for a given task. I mean, that is just a masterclass in efficiency.
Okay, so it's efficient, we get that. But the real question is, can this leaner design actually go toe-to-toe with the heavyweights? Let's take a look at the benchmarks. On those agentic tasks we talked about, using tools, interacting with environments, it pulls off a very impressive second place. It's nipping at the heels of OpenAI's super powerful O3 model. Now, in the world of coding, it grabs a strong third place. That's outperforming some really well-known models like GPT 4.1 and Gemini 2.5 Pro on incredibly complex real-world coding tests. And when you average it all out across the 12 toughest ARC benchmarks, GLM 4.5 lands in an incredible third place overall among all the models they evaluated. For an open-source project, that is a huge, huge achievement. So how in the world did the team pull this off? How did they get this level of performance out of such an efficient design? Let's peek behind the curtain at the training process.
Well, the secret sauce seems to be this meticulous, multi-stage training recipe. It started with a gigantic base of general knowledge, 15 trillion tokens. Then they specialized it with another 7 trillion tokens all focused on code and math. To put 23 trillion tokens in perspective, that's like reading the entire English Wikipedia tens of thousands of times over. It's just a staggering amount of data.
But it wasn't just about throwing massive amounts of data at it. They made some really clever design choices too. For example, think about how an AI talks to other software. It's usually a total mess of weird characters and clunky formatting. Well, the team here developed a much cleaner system using simple tags, which made it way more natural and efficient for the AI to learn. And then, during that final post-training phase, they used some really smart reinforcement learning techniques. They put the model through a difficulty-based curriculum, starting with easier problems and ramping up to extremely hard ones. They also used a cool process called iterative self-distillation,
where the model basically teaches itself how to get better and better.
Okay, so let's pull back to the really big picture here. We have an efficient, powerful, open source model. Why does that actually matter so much?
Honestly, the creators themselves say it best. Their whole goal is to advance research and applications for everyone, not just for a select few. 355 billion parameters. To make a model of this scale, with this kind of top-tier performance, completely open source, that is a massive deal. It's like putting a supercar engine into the hands of every mechanic in the world. So what all this really means is that state-of-the-art AI is becoming more democratic. Its efficiency lowers the barrier to entry for everybody. And by finally filling that critical arc gap in the open source community, it creates a powerful new launchpad for a whole new wave of global innovation. So this release, it really isn't an endpoint. In a lot of ways, it feels more like a starting gun. By putting this level of agentic, reasoning, and coding ability into the hands of developers everywhere, it raises a really exciting question for all of us. What comes next?